Okay, this is my 150 gram 4-wheel drive pushy bot called Big Yarn. At a recent testing day, I found that there was a few mistakes in the design, so I want to do a rebuild of it to try to fix up these little errors. Currently, this is on revision 6 of the design, so we're going to go up to revision 7. I want to do a bit of an explanation about why it's already up to revision 6, even though this robot's only about 6 months old. Okay, this is my original 2-wheel drive pushy bot that I used. It usually had the big wheels on the back. This robot I actually took to America and competed at the 2012 Robo Games, where I actually managed to pick up a second place. So yeah, there's proof. So technically this was the second best 150 gram robot at the time according to the American competitions.
Your winner, Vendetta.
This was the next version of Vendetta Junior, so I originally planned to have 4-wheel drive, try to get some extra control, because that's what the guy who beat me at Robo Games had, so I was trying to copy him. But it was a bit of a disaster, and yeah, as you can see, I don't even look after it very well. This is kind of rubbish. And then at the start of the year, when the Ipswich Robotic Sports Club started up their antweight competitions, I decided to rebuild my little 2-wheel drive, 4-wheel drive pushy bot. And this is what I started with. So this is Big Yarn. So this is the same robot, new name. So this one was laser cut using some scrap that I had at school. It originally had 2 4-wheel drive, well it wasn't 4-wheel drive, it was actually tracks. That was the idea of it. So I had rubber band tracks. Rubber band tracks are an extremely bad idea, never use them. This robot is scrap. Okay, then I went to revision 2, so this was revision 2 of Big Yarn. Tried to move the wheels forward and make some extra room on the inside. Unfortunately I couldn't actually fit the speed controllers in, so I had to quickly knock up a new version 3. So this is version 3. Replaced the rubber bands with O-rings. The problem was that the O-ring, the drive motors were connected to the front wheel, and the O-rings were actually pulling on the motor shaft and twisting it, which jammed up the whole drive, and the whole thing didn't work. So that robot was a disaster as well. Okay, so this is revision 4. It's exactly the same, only 3D printed, because I bought a 3D printer. Yay! Exactly the same, except the motors, which you can't really see because it's black, but the motors were no longer attached to the front wheels, and there was a gear running between the motor shaft and the rear wheel. That way the force of the O-rings was no longer twisting the motor shaft. The problem with that, this version was the motors kept falling out and the whole thing didn't drive, so yet again another disaster that needed rebuilding because it did not move. Okay, so this is revision 5, exactly the same layout. The motors were still in the middle with gears attaching the motors to the rear drive, that way there was no force on the motor. And this time the motors are mounted into the chassis here, and then a top plate was bolted on to hold the motors in place, which worked extremely well. They still had the problem with the force of the O-rings locking the wheels up, so I actually ran this with only one O-ring on the tracks, which wasn't really what I wanted. I wanted redundancy on the O-rings, and so this performed all right, but it needed improving, so then I went to revision 6. And this is revision 6, so the motors are still in the same spot with the top plate holding them in place. The only difference is that instead of having the big wheel on the back and the small on the front wheel tracks, O-ring tracks running between, it's now just 4-wheel drive. Also sharpened the wedge a little bit. Other than that, it's exactly the same robot. Now, the problem with this robot though is that when I found out on the testing days, when it's upside down, all the weight is resting on this section at the front, and there's not much weight on the wheel, so it doesn't drive very well. So what I want to do is I want to use these little ball bearings that I use in the wheels and mount 2 to the front of the wedge at the top. That way it rolls around on those ball bearings and hopefully drives a little better. The other change I want to make is I'm currently using these single channel speed controllers, which are alright, but the problem is I use this radio here, which is a 2-channel wheel radio, but it has no internal mixing on the radio, so I have to have a mixer here, which means I have all these extra wires, and I think half the weight is just in the electronics trying to get all that to work. So what I want to do is I want to replace these single speed controllers with the dual channel speed controller that I'm currently using in Slightly Mad Angus. So this one has internal mixing. What that'll mean is I'll have one single speed controller this size to control both motors, so I won't need that speed controller, and I won't need this mixer, and I won't need all this bundle of wires. So I'll be able to reduce the amount of wires in here, which will reduce the weight of the robot and reduce the weight sitting on the front. I also want to put a base plate on here to try to cover all that up, because even though I've never had a robot hit on the underside, which is extremely surprising, I think one day it's going to happen, so I need a base plate over here, and then if I have a base plate I need an on-off switch on the top to turn the bloody thing on and off. So the 4 changes I need to make are the casters on the front, replace the speed controllers, put a base plate on it, and put a switch on the top, and that would be revision 7.
First thing I need to do is update the Inventor model for Big Yarn. So start off by putting in the location for the caster mounts, and then draw the little profiles for the caster mounts. So these are the caster mounts going on right now. I only need to do one sketch for this, and I pattern it across. So it's actually mirrored across twice. There we go. Looks good. Second step is to update all the text on the top. It had 5 extra wins and a loss since its last fight, so it's getting quite a lot on there. It actually takes me longer to update the text on the robot than it does to actually draw the rest of the parts. So there we go, text going on. I then open up the model for Slightly Mad Angus and take the dimensions for the switch, and then use the same size switch on Big Yarn. So just copying the switch mount across. Yep, looks good. Now I've got to update the top panel so that it actually fits around the switch, because the switch isn't enough room there. Yep, looks good. Now I've got to do the bottom panel, so drawing in the mounts at the moment. So these are the mounts for the bottom panel. And then I actually add the dimensions and drawings for the panel itself, even though I don't actually extrude it in this model. I'll derive that across to a separate model later. There we go, just updating the casters a bit better. Okay, now making the bottom panel by deriving the sketches across. So there's the bottom panel. Put that into the assembly, make sure it fits, all looks good. And then put that into the Cura to 3D print. Here's my Tronxy, so I can print on that. Unfortunately, I only have one PowerPoint in the garage, so I can't plug in the lights and the printer at the same time, so these videos are a little bit dark. There we go, lay down the raft. So much stringing on my models. All those strings. Okay, this print actually took 23 hours to print, so it's quite a long time. I'm a rather patient person when it comes to printing, so I don't mind if it takes more than 20 hours to print something. Here is the finished 3D print for version 7. Cleaned up alright, so it looks alright. I've already tried putting in the first caster on the top. There's the top panels for it and the bottom panel. I've also printed a new set of rear wheels for it. There's the old version. So now I just need to strip apart the old version, pull the electronics out and put it into the new version. Okay, the first step to do is to have the other caster on. Pretty easy, just a little screw running through. Okay, now pull apart the previous version of Big Yarn. That little mouse you can hear squealing in the background is actually Alice playing her playpen. It's been sped up 4 times, she's a bit squeaky. Now I've just got to pull the motors out, and the speed controllers were held in with hot glue, so they're actually quite hard to pull out. have to use a screwdriver to sort of pry them out. I love hot glue. Okay, you can see how big the previous electronics were. Just remove the motors from the previous lot of electronics. Keep them for the new robot. Check that they fit. Now this is pulling the speed controller out of Slightly Mad Angus. They don't actually write on the speed controller which wires is which, so I'm just putting the servo leads back on straight away before I forget, because I use the different size servo leads for the different robots. Now take the power lines off, then disconnect the motors, then hold it in place with a clamp so that I can put the motor leads back on, because I didn't really want to unsolder the motor leads at the motors in Slightly Mad Angus, so I'm just using new motor leads on this version. There we go, my awesome soldering skills. Now to solder the new power lines on. I'm soldering the on-off switch directly to the board just so I can save on using heat shrink. I should only use one piece of heat shrink. I think I actually soldered myself while doing this. I'm good at that. Put the single piece of heat shrink on, which is pretty cool. I hate heat shrink. Awesome. Now I have everything installed in the new robot. I want to put the gears on and test to see whether or not the motors are turning the right direction. So I set it up and give it a bit of a test drive, even though there's no wheels on it. And it turns out one motor was actually wired in backwards, which I tend to do quite a lot. So quickly pull the motor out and wire on some new reverse the wire polarity on it. Give it another test to see how that drives. Put it back in, put the gear back on so I can see what I'm doing, and everything's turning the right way. Awesome. Okay, now to put the front wheels on. Front wheel is held on with an M3 screw and a nut on the inside. It's just a bit hard to get the nut on while the electronics are on the inside, but yeah, we managed to get it on. The other wheel goes on a little bit easier. Cool. The back wheels are held on, there we go, with an M3 threaded rod that runs all the way through, with a nut on each end. So just grab hold of the nut on each end to give it a few twists. There we go. Main problem with this is that the threaded rod's too long and I really need to cut it short. Now just put the top plate on and we're finished. So on goes the top plate, and Big Young version 7 is ready to fight. Cool. Just checked on the scales, this robot weighs 134 grams, so it's actually lighter even though it has base plate and casters on it. So those new speed controllers are cool.